Hello, everyone. Welcome to this conversation on how we will make progress on Julia and statistics. We've got a bunch of remarkable people here on this call. In the metadata of this video, you will see their profiles. And I would like to get started with the substantive conversation. So our first question, what is our assessment of the strengths and weaknesses of Julia as a foundation for doing statistics, not the state of statistics in Julia, but rather that if we apply in our mind's eye, if we think some time into the future when a lot of things are fixed up, what's the opportunity, what's the potential, how do we see this evolving, that in what ways are we attracted that there is something good and important here which can make our life in statistical programming better. So can I first ask you for the vision of what is it that makes you feel good about doing statistics programming in Julia? Professor Bates, can I please turn to you?
Yeah, I, of course, feel very strongly about avoiding the two language problems. You know, my background, I worked for a long time on mixed effects modeling in R and had to write either in R and C or in R and C++ and RCPP and RCPP eigen and trying to bring in sparse matrices and all of that sort of stuff. So it just became too difficult. You're juggling too many different interfaces, different languages. So when Julia came along and I first heard about it, it was just sort of, wow, they can do that. And I became very enthusiastic right away. So I think that that's the basic value that Julia brings to people doing statistical computing is the same that it brings to a lot of people in technical computing areas, that you can get the performance of the low-level compiled language while working in the high-level dynamically typed language. That's from the developer's point of view. From the user's point of view, it's, oh, this can be done. You know, I switched to assessing variability parameter estimates in some models just by using parametric bootstrap. And why? Because I can fit these models over and over again, tens of thousands of times, and do that in a very short period of time. So it's also composability, the package system, the sort of zen of developing a Julia package is much more disciplined. You know, it's expected that you're going to have continuous integration. It's expected that you're going to have, you know, test-driven development and so on. So all of those aspects make it attractive for long-term prospects. The difficulty is that you have to convince people that it's worthwhile learning something new. And that's always an impediment. You have to provide some sort of short-term benefit, which sometimes can be just, oh, this package exists there, which is where I think that the interface packages, you know, rcall, pycall, Julia call from either of those is useful because it allows people to, you know, dabble their feet in the water and learn a little bit about the language. I'm still at the point where when I do some analyses, I fall back on R through rcall for doing the plots. You know, I love what people are doing in Maki. I love the work on algebra of graphics. I'm better at using lattice or ggplotting. So when you need to get something done, having a familiar tool is very important too. So I see the long-term benefits as just it's a very solid language. It's a language that's built on a very good foundation, but it's still being built. So you don't have all of the nice turrets and towers in the language at present. And that's going to appeal to a type of user who's more on the developer end than on the strict, I got to get this report out by 3 o'clock and I don't have time to learn everything that I need to know before then. Let me pass at that point. Somebody else can take over.
No.
So yeah, I think I agree with all that. Although one thing that I do want to note that like I think makes Julia such a sort of an amazing foundation is just even for people who especially I guess for people who wouldn't have to learn something new because they don't have something old that they already know. So people like for instance, I would probably not be a developer or working on statistics or programming at all if it weren't for Julia, because this is actually it's like a I am usually the kind of person who was a lot more interested in statistics or mathematics or applied modeling than I am in actually coding, and I do not know actually a lower level language like C++ or something like that, and then just being able to right away get straight into Julia and immediately be able to write like I'm used to in Python or R or something simple like that, and have it be actually like usable for a package that I want to build instead of having to learn a completely new language is honestly, it's amazing. And I think that that's a great advantage of Julia, that we can get people in so quickly and help them get contributing to the package community so easily, when in the Python community or the R community, you would have to spend God knows how long first learning C++.
Sourish, you grew up in the R world. What has been your experience in the transition?
Yeah, I grew up in the R world, and so I just started learning Julia in Jan 2022. So I'm just baby in that sense. I'm 6-month-old in terms of Julia world. So what I found astonishing, I mean, speed is definitely because it's a native language. I mean, you're writing, you don't have to worry about the 2-language problem as Persepates mentioned. So speed is definitely something, but what really surprised me when I started using Turing.jl, like the way I can write the code, like I can when the way I teach Bayesian statistics in class, effectively whatever I'm writing on the board, in the blackboard, that directly goes into my code and that runs. And that was like, wow. I mean, if I shows this to my students, they will be like, I mean, the way you write mathematics, that can be codified and that can run and give you the results. That is what actually like make me really, really interested about Julia. And I hope that going forward, the package I would like to develop will have all those features of Turing.jl, because that is something, it's abstract, but it's absolutely beautiful, because the way you write mathematics, you can codify that in is something is just beyond me. So yeah, speed, I mean, maybe 10 years down the lane, there could be another language which will beat Julia. I mean, then there will be maybe in 20 years down the lane, there will be quantum laptop. I mean, there is no end in the speed. I mean, and we know this game. But the thing that really surprises me is that the way you can you can code the language. That's really surprised me. And I am all immersed in Julia for now, last 6 months.
Vijay, tell us your thought process and decisions around this.
Yeah, so first of all, thank you for this. One of the most important things that the two aspects I have two hats. I have an academic hat, and I also develop products that are commercially sold in Julius. So I want to give you both perspectives. I've been teaching R, and I'm not a developer. I've never been trained in any programming language, but I've been teaching R for statistics and everything that is rated in pharma for the last almost 12 years, right? And back in 2016 or 17, I came across a problem where I am not making it up. I had to use a mix of Python, Perl, Fortran, and R, which I spent about 8 months working on. And that turned out, when I actually discovered Julia, and I used, I think at that point, Julia DB, which is still there, I ended up doing that entire project in one language in literally 2 months, right? And that opened up a lot for me, right? So that was more from a research perspective. And then I realized, man, if I could actually make this happen for people like me in the industry, this would be great. And that's how, the whole productization of what I'm doing happened, right? But from an academic perspective, I completely agree with Sourish in the fact that you codify the mathematics that you write and you're able to teach. That's a completely beautiful thing, because then it's simple. What you write is what you see. It's like the editor. What you write is what you get, kind of. What you write is what you see, and that actually made things a lot more simpler. And that goes to the next point of actually what Professor Bates just mentioned, that it's important to teach, and how you teach, to what Carlos also said, imagine teaching somebody who's already learned R for a long time versus somebody who's coming in new. I think for the newer generation of population, it's so much more easier to teach statistics if you are in this interface than if you have to go through a simple kind of interface where you have to write everything else. So there's a little bit of there's a beauty plus brains kind of thing that's going on here, in my opinion.
Bogumil, do you want to jump into this?
Yeah, so I was thinking what to add, and because there were many topics already covered, but I would say that what is important, especially important in terms of statistics, is one thing that Vijay just mentioned, but also it could be heard earlier, that Julia's strengths become apparent when you start to need to do something longer than 30 or 50 lines of script. So once you really need to develop a solution that is really a bigger project, not just a toy example, that you do on your class assignment, then you can see that the way Julia, in a sense, gives you tools, but also forces you to structure your thinking, allows you to be more productive in the long run. And this more productive, of course, part of it is performance, but I would say it's also just developer or statistician in the context of our discussion, performance in terms of how much you can pull off in, I don't know, 1 week or 1 month. And I know Python, I know R, I know everything, all those standard programming languages. As many of you also mentioned, every one of us work with different languages. But when I start a new project and I ask myself, which tool should I use to spend least time to get the result, then recently I always choose Julia. So because I end up, for example, deciding that what base Julia offers, not even speaking about the packages, but what base Julia offers is like a perfect mix of basic functionalities that you need to build algorithms around working with array-like data. And this is something you don't have in Python, you don't have it in R. Of course, they have functionalities that allow you to work with arrays, but this is always feels like kind of add-on to the language. Actually, in Python, it's an add-on. In R, it's inbuilt, but it's not convenient. In Julia, simply the set of choices, even in base Julia that was made, makes it easy to develop new things, or I would say in general, to implement algorithms. But, and the thing is that the biggest benefits of it you see when you need to do something bigger, because at least this is my perspective, that if I need to do just, reading the data and create a correlation matrix, then probably there is not big difference in which language you implement it. But once you start building something larger, especially that has to go to production later, then the benefits of Julia, I think, are quite significant.
One thing I would like to add to Professor Bogumil's what he just said about performance. I totally agree with him. And having worked with R for many years, I mean, I have no formal training in statistics. My background is computer science. So I have used, I transitioned into R. It was a long learning curve to think about vectors and matrices as the base on which objects on which to perform. And then when again a little learning curve to migrate into Julia, as Sourish said, I'm also like a 6-month-old infant in this ecosystem. But what I did notice is in terms of let's say performance, is that Julia makes you think about performance of your code inherently. I mean, it's there, it's built like that. So for example, in R, I learned it over the years that there are things which you learn. So the memory, the garbage collection about the memory, copy and write, you're working with data frames, you change one column, another data frame gets created, and how the garbage collection works. So all those things which you learn over the years. But here in Julia, what I saw is that even the Julia documentation mentions it very clearly. Even the generic interfaces are built like that to support in place modifications of an object, for example. That is something which I just loved about the language, that the standards are in place to have that performance thinking, and of course thinking about the types that's inherently again built within the language.
Yeah, but here, for example, if you mention this is something I, as a maintainer of data frames JL, I always have a challenge with this. What I mean by this is that we indeed expose, various possibilities, because you can copy data, not copy data, and you have full control of what you can do. But on the other hand, I always think, okay, so for expert, this is very good. But the question is, and maybe you can comment, when you were doing the transition from R, isn't it creating a kind of steep learning curve that user comes and sees, I have so many options, I don't know even if I need them, so why do I need to learn them?
I guess for me, it was a little easier because I had faced those problems. And at one point, there was one project where I was working and was handling some 100 millions of transactions a day, that kind of data. And then you had to think about these issues. The data wouldn't fit into the computer RAM, and then you have like multiple computers. You offload the computation to different machines, and then your program crashes out of memory, and then you're thinking, okay, what is happening? Why is it happening, right? So, and that experience I felt sort of helped me. But I do think it could be confusing for somebody who's not seen this problem or had not had this problem or think about it. So yeah, I mean, I can think that, okay, why do I need to modify the object in place? Why can't I create copies, right? So that is obviously there.
Can I segue into a next block of discussion? This is about the tension between building a Julia statistics ecosystem that speaks more native Julia, that is rooted in Julia idiom, that is rooted in the modern computer science that is in Julia, versus the objective of easing the transition path for people who are coming from R or coming from Python and are looking for something more familiar. Okay, there will always be that tension. And how should we approach this question? What are the right ways to make those trade-offs? Bogumil, you have often talked about the question of missing data. I feel that in the field of statistics, we've really got to have transparent, standard default handling of missing data all the time by the underlying tools without requiring overhead on the part of the user, because handling missing data in a certain sensible way, as is done in R, should really be in the infrastructure of a statistical programming system. So I can see how it was important for Julia to implement missing data in a certain way. And there are domains where missing data is viewed differently. But for us as statisticians, observations that have missing data is just completely normal and is a part of our bread and butter. So how should we build a world of statistics and language syntax and packages which are good for the Julia statistics world? And then how should we deal with this tension between the old user base of R and Python versus what is cool and elegant and high quality, what we can build for the next generation in Julia, while leaving some of the old users behind sometimes?
Yeah, so if we mention missings, let me just comment on two examples of the tensions that we have here. So for example, by default, Julia collections like vectors do not allow missing values unless you tell Julia that you want to allow them. So what is the reason for this? There are three kinds of reasons. First reason is that as a user, you can explicitly say, I don't want to allow missings. And if someone tries to put a missing into this vector, I want an error, because I expect this as a contract not to allow missings. And I think it's quite often useful to have this constraint, because then you have a quick fail of your computations. The second aspect is performance. So not allowing missing values in vectors gives you a bit better performance. Not a big difference, but there is a small benefit of not having missing values for your computations. Third thing is that if you have a vector that doesn't allow missing values by default, this vector uses less memory. So in a sense, you have a situation where not allowing missing values uses less memory, is a bit more performant, and sometimes it's wanted. But on the other hand, as you have said, in statistics, because in other fields like engineering, you very often don't even need missing values. So then people say, this is exactly the choice that we want. But in statistics, this is a opposite from the perspective that most often you would have those missing values. And then you can have to constantly think of how to handle them. And the second, so this is kind of low level consideration. And the second aspect is, for example, treating missings in conditions. So what I mean by this, most users, when they say, I want to filter, for example, data frame by some condition, intuitively think that missing value should be dropped when filtering. While in Julia, it will be an error if you encounter missing value, because you will learn that missing is not a Boolean condition. But now you can think, okay, but why do we have it? And the answer is because sometimes actually you want, for example, missing to be treated as true, not as false. So you say, okay, if I have a missing, I do not want it to be dropped by default. So here we have a kind of tension that there is some behavior like dropping missings when you filter some collection, which is 90% of cases correct, but 10% of times is exactly not what you want. So if it happens by default, then you get a wrong result. But on the other hand, and this is what we have in Julia, at least by default, is that you have to be explicit how you want to handle missing values, but this gives an additional mental burden that in your code you have to do an explicit handling of missing, for example, using coalesce. So you say coalesce X, either true and false, and then you are happy with the condition, but you have to be explicit, while normally people would just write a condition and expect that missing would be dropped. So this is a kind of thing that, again, I am very used to using Julia, so it's not a problem for me when I write my code. But I am always thinking, okay, if newcomers don't find it too demanding to constantly have to think of how to handle missing instead of having the default that is most of the time correct. And I'm not sure which is the best way here.
I would contrast the way that Julia handles missing data with the way that R handles missing data. And R was derived from an earlier language called S, and S was specifically designed to be working on data science, statistical sorts of applications. And they made a decision to incorporate missing data at a very low level. So all of the vector types in R have a missing data sentinel. And it's like one of the NaN values for floating point, and it's the minimum negative value for integers and so forth. But what that means is that every time that you process a vector in R, you have to have the loop in there to check for the missing value sentinel. And that's just not going to fly in Julia, because Julia is used by people who don't have missing data and who are not willing to allow that kind of performance hit. So yes, R does it in such a way that it's very convenient and low mental overhead for working with missing data, but it comes with a performance penalty. And I think that in my experience, it's not too much to expect people to think more about how they work with missing data if the benefit is performance.
Can I take us back to the more abstract discussion? How should we think about the tension between building things in a Julia native way versus building things that are more accessible and recognizable to people coming in from R and from Python? Ayush, can you describe your experience in building the survey package, the tension between building something that's clean and nice in Julia versus building something that looks more like Thomas Lumley's beautiful survey package in R?
Yeah, so, and Bogumil has also in an issue pointed it out that maybe it's a better idea to do it in a more Julia way. But yeah, I just felt that there's so many resources available by Professor Lumley. The first version was released in 2000, version 1.0 was released in 2003. And since then, there have been so many documents, so many talks, books, and so on the package. And there are examples, there are discussions on R-help and stat store stack exchange. So it's just that the resources are so widely available that I feel that the transition will be very smooth if the syntax is similar. And also from my own perspective of as a developer, it's a bit easier. And so there's a quote by Thomas Lumley that we don't care about speed in the package and we only care about expressivity. So he is really focused on expressivity. And internally, he has sacrificed speed. And he has said that there's no need to fix it until someone really starts complaining. And because data is getting bigger and bigger now, so we are complaining now, but simply moving it to Julia has increased the speed by more than 100 times. And actually internally it's different. So for example, I think he's not using group by and combine that effectively. And because it's so well done in data frames, so internally the code is very simple. There's like some group by and some combine, it's a lot faster. If I were to use a direct translation and do a search operation, then it would be a lot slower. So internally, it's not a direct translation. It's written in a Julia way, but it's just that the API is very similar to the R API. It's not exactly the same because I can't do it, but it's very similar, and I've kept it like that so that people can transition.
So I have a point just to piggyback on Ayush's thing, right? So the question here is, what are we trying to achieve in developing the Julia Stats ecosystem? We're not trying to compete against R. We're trying to build a new ecosystem and an ecosystem that is here to stay. It's okay for people to use multiple languages. People will always use multiple languages. I think that's a realization that I've come across when trying to put a product out there that's competing against a 60-year-old elephant that's there. And, you know, I know what Doug Bates is laughing, but he knows exactly what I'm talking about, right? It's been developed in 1965, 70, and the entire pharma community is still using Fortran 77 and Fortran 90, right? So it's okay for people to use other tools, but I think what is really happening is, in my opinion, if I was trying to be in a governance system for this, I wouldn't try to replicate what's out there, but I would instead invest the efforts into increasing the resources, the education around this. I will tell you, you know, till 2009, 2010, if you look at the growth of R, it was okay. It was growing up, but it was not crazy. People were still using SAS a lot. It was only after R Studio's platform launched and they had the simple knitter and publish to R pubs came, people started realizing that, hey, you know what? I can write something and hit publish and my article can go online. They don't have to know anything about coding, about HTML, about websites. And now everybody became a hobby statistician. Everybody became a hobby blogger. Everybody became a hobby trainer. And that is what we don't have in Julia yet. I mean, I'm sure there are packages out there, but it has not become that prevalent. And I think our focus should be on developing the best tools, not worry about pulling people from other tools. As long as we have enough good educational material, I would rather go for that than trying to pull people from other, because you can't change people's habits. If I'm used to brushing my teeth after having my breakfast, you can't force me to have my breakfast and then brush my teeth, right? It's just the way it is, right? So I think it's just going to evolve over a period of time.
So one thing I want to add, so you asked why are we developing this? So actually, I mean, the real reason why I first started writing that code was for an internal thing. So we use a very large survey data set, and it is a usual sight in our office to see people start a code and then leave their laptop a little open for like 5-6 hours. So and then I did it once. It was the first time I was using that data set, and I just could not believe that it was taking so long. So it was actually for me and for like our team that we started doing it. And then even though I've made the code so similar to R, they've still not moved from R. So it's actually just me who is using it right now. But that was actually the purpose of making the package.
No, I understand. I was using that as a context to say that I think a focus should be on education and develop the tool in the right way that is more Julia automatic. That's just my way of thinking.
I was attracted by Turing because I feel that they have pushed the global frontier of how to do Bayesian statistics, and it is completely incompatible with every other system, but it is great. It is really remarkable. And I feel, that's the kind of work we should aim to do, because it just takes us to a different level altogether. It lays the foundation for doing better science in the future. So I'm so excited about using Julia as a foundation to do transformative things. And so, when I look at the work done in data frames, when I look at the work done in Turing, I really get inspired that we should push the frontier, and that will often mean breaking familiar APIs.
So just, one of the other reasons why we copy stuff, I'm primarily about since we are discussing, the tension between bringing in users from existing languages like R and Python, it's also the ease of use. For me, of course, my opinion is definitely biased because I've worked with R for quite many years. But there are many things which I just, as a user, find them easier. The interfaces are just easier than what I see with some packages, with certain operations, than they are in Julia. So while building a new package, expressivity, as Ayush mentioned, the ease of use also becomes an important point. That it should be, the interfaces should be more, how do I put it, intuitive, more natural. You just feel natural. Okay, if I write this expression, I expect that this is, this should be the default, or this should be the argument name. All right. So that is another reason for that sort of tension. Even though you want to do it in the Julia way, not provide it as a mandatory argument, but then with R you can, everything is a keyword argument, right? So just a little example. So you think hard about which should be the keyword argument, which should be the mandatory, and set some certain sensible defaults.
So I think that's a very important thing, because now transitioning from R to Julia for the survey, because everything in R is like a keyword argument. So that was really difficult. But at the same time, it's kind of nice in R that you can tell what parameter it is, right? Like if you have f of like 10 parameters, then you can like tell like if x equal to 1, y equal to 1. So I think that's quite nice in R, which is not there in Julia. And it was really painful for me in survey to do it, because then I couldn't do multiple dispatch with keyword arguments. So yeah.
Can I go on to a next question? Bogumil, you have often emphasized that we've got some work to do on the foundations. How do we improve the convenience of using Julia stats? How do you think of base Julia? How do you think of statistics and stats base? That, how do we reduce the entropy in these foundations, and what's our way to fix some of these elementary things?
Yes, so at least my perspective is that let me first comment what, at least from my perspective, the tension is. So I believe that we need some statistical functionality built into the language, because when people want to calculate, I don't know, mean, they don't want to have to install a package, because it seems to be an overkill for many standard simple functions to have to install something. But on the other hand, very quickly you learn that those functions that are provided by statistics.jl, so the standard module, are limited, and you anyway need to have additional packages. For example, the core of the things is, I think, weights, but because other functionalities that are missing in statistics, like order statistics and this kind of things, this is a separate thing. But then if you decide you need something in standard distribution of Julia, then you very quickly hit another problem, that if something is in standard distribution of Julia, you have a limitation that you cannot develop it too fast, because it will be only released as the Julia is released, and also if you like to change something, you cannot change it because of the non-breaking policy in base Julia. So, so this is something that I think is really difficult and challenging. At least my perspective would be to have a more complete package that is designed for support basic statistical functionality. So to merge statistics and stats base somehow into one package, but whether it should go into whether then it should be statistics a standard library module, or rather this should be taken out as a separate separate package that has to be installed. I'm not sure. I would go for having a standard module, but as I have said, I understand that this will bring us significant limitations in how fast we can develop. So this is at least the tensions I feel, but my thinking would be to leave statistics in base, to have this standard functionality, but try adding things that we are sure that we want added, so that the feature functionality is more complete from the statistical user's perspective. Why I mentioned this, maybe the issue is that for example, those weights, this is something you need almost all the time when you do statistics. But for example, there are people in engineering who need to calculate means quantiles, and most of the time they don't need weights in their computations because they have equal weights in all of their data. So this simpler functionality that is currently provided is enough for them. But from the statistical user's perspective, which I understand we discussed today, is and I am within this bandwagon. I think that we should put more functionality into statistics module, that it's more feature completed. This is my thinking, but maybe especially you who have migrated recently from R, you can comment how you find it. Oh, you are muted.
Do others have comments on this question? Okay, we are towards the end of our panel discussion. I would like to just go to our most important question. What's our way forward? What are the priorities for what needs to be done in building the Julia statistics ecosystem? How should we organize ourselves to be more effective? How should we coordinate between all of us on this call and the 100 other important people who are developing in this world? So what are your thoughts on the way forward? What are our priorities and how should we go about doing it?
For me, I would say we really need a way forward to evangelize and educate folks better. I had to use the word evangelize because it's important to continuously be out there and tell people. Ayush is doing it in its own ways in his office, but nobody is listening to him. But eventually that shift will happen. I'm in the same space in the pharma community where we're trying to move, and it'll take time. We know it's going to take a few years, but the early adopters are already loving it. It's just a matter of time. So it's about putting out the right education and evangelizing it and standing by it. I think that's more important. And there's no question that we have to make it easy, right? There are always comparisons that will be made to R, but I think in one area of focus should be education.
Carlos, what are your thoughts on the way forward?
Yeah, so I think I agree. Mentioning on sort of bringing up Bogumil's point on having sort of this discrepancy between what in stats-based sort of thing. I've been wondering if there's like more we can do to make it clear to new users what are the packages that they are very likely to need. What's the sort of thing that it would be really great, definitely, to have just a sort of more more resources to help welcome people into the community and understand sort of like what they are going to need when they are starting out, so they don't have to figure out like what's the difference between statistics and stats based, why are different things in each one, sort of thing. And even just for a lot of other packages, it's, I think, very common in Julia to try to split everything up into as many different packages as possible. And that can be definitely very intimidating for new users. And I think we should be trying to make more efforts to sort of collect more of these packages together, and make it easier for users to figure out what it is they're going to be needing.
Professor Bates, what are your thoughts on the way forward? How should we organize ourselves? How should we do community building? How should we coordinate better with each other?
Yeah, there's always that tension there that Carlos mentioned between having the Uber package, which is going to encompass everything, and having a number of small packages. I don't know whether one of the advantages of Julia is that it has the composability aspect to it. And we've seen that with packages that really don't have content, like data API, that are just there to knit together other packages in terms of defining some generics. So it may be possible to think of some kind of statistics toolbox. And I think that that would be tied in with trying to teach courses. And fortunately, I'm out of that game now, but I don't know what, do we want to think about an introductory course in statistics? What would be needed in Julia, or do we want to think of more advanced specialized courses? I think we're still at the point of advanced specialized courses, but the concept of what the community is becoming much more diverse. We have people who would identify themselves as data scientists who may not be interested in statistics in the sense of distribution and probability and statistics and the typical model fitting, but they're definitely looking at the streams for data and so on. We have people in machine learning, which still is a bit mysterious to me. And how do these communities, they at least should be talking with each other, people in Julia community who are active in these. Do they need to be somehow knitted together? I'm not sure. It seems that there's a lot of tension between coalescing and diffusion, and we're going to have to feel our way through to decide exactly how we can balance those forces.
Sourish, what are your thoughts on the way forward? What should we be doing? What are our priorities? And how should we as a community organize ourselves to get things done more effectively?
Well, I think a couple of things we need to done very quickly. One is, for example, what Bogumil says, that missing data handling is a very different story in Julia. So maybe we can put up some training material of how to handling missing data, because in typical R Python, that is, we take it for granted, but in Julia it's not. So I think the aspect which is not so obvious in Julia, more training material, YouTube video would be something we should take on priority basis. Another point, I think, with Professor Betts, what he mentioned, that maybe some more material on, say, introduction to probability and statistics with Julia. Those kind of material needs to put on. So I think more training material, what Vijay says, is more important. And also the aspect of this Unicode aspect of Julia, like, you can use effectively Greek letters in your coding. That is, I think, absolutely beautiful thing of Julia. So I think that could be one of the unique selling point of Julia. And I believe we should stress on those. I think, like, it is like being a statistician, being trained statistician, we always think like, like equations first, and the Greek letters and the equations comes naturally to us. So, and you can codify it so easily. That is one of the very strong point of Julia, and that should be one of the part of our training material. So, and things, I believe, as Vijay mentioned, that things will fall in place. So we are not in rush. So I think that is what, and of course, building up the community, reaching out to each other is and Julia Discourse is great place to be. We need to introduce our students. I'm pushing my students to be active on the Julia Discourse. So, pushing our students to take part in the Julia Discourse is also another thing that we can encourage our students to be on. So these are the things, I think, small things we have to keep doing.
So I think I totally agree with what Vijay has said, and Professor Bates and Sourish have carried forward, is the training and education, because I feel all of us scientists and engineers here, we can sit in our garages and keep working on our little products, but what we do really need is more and more users, really. So we need to get out there. We need to reach those people out there who are using data, whether there's data scientists or statisticians, to use the products which we are building, to use the language and the packages. The more users we have, the more evolution we will see. The packages will become better. So, yeah.
Bogumil, over to you for the last word.
Yeah, so my thinking is that maybe let me comment on the coordination efforts from the perspective that was related to those interface packages. So I think that a lot of things will be easier if we really focus on thinking of those high-level abstractions that we can put into packages. Currently, there is a data API package and stats API package. Those two packages are meant to be interface packages, and I think that really there are a lot of functions that could be put there, and if we standardize their meaning, it would make things much easier, because even such a simple function as predict, I don't know if you stumbled on it or not yet, but predict is not standardized in this way. And then if you use several packages that allow you to do prediction from a model, you have several predict functions imported, and then there is a name clash. So this is maybe not a super, I hope this is not a very complex thing to do, but at the same time, it would make teaching, learning, and using Julia easier, because then you can say, there is a predict function, for example. It's in general meant for prediction. And whatever package you use, there is some common interface agreed how it should be defined. And all the packages that support predict function follow it the same way. And then you have two benefits. One benefit is that you learn it once and reuse the knowledge, but the other is also that such a common and intuitive name can be easily reused across packages, because currently if you have a common name, you have to really think strongly whether you want conflict with something else that is out there in the package ecosystem.
So Bogumil, how should we solve the coordination problem where a whole bunch of us need to come together and debate this and come to some of these standards? Because Sourish here has taken a different strategy. He's building the CRRAW package. He's saying to himself, look, I'm not waiting for the entire community to coordinate around, but within the domain of my one new beautiful package, I'm giving you this consistent API to a whole bunch of statistical estimators. And so he's making progress, but he's not solving the larger problem. And I see value in both, that it's good that he's building this package and it is giving you a simple, harmonious, consistent API for a wide variety of statistical models. But we also need to solve your problem, which is that there should be a predict generic. So how should we go about it? How should we have a debate and write a standard? It sounds to me like an RFC problem.
Yeah, so I think, of course, this is not a simple task, but what I would say that, if you move forward with exactly what you have described, then eventually it will become a de facto standard. But the thing is, because this is the crucial thing is here about naming. So if you see a function that actually you believe that the name, because the crucial thing here is a name, because it's related to name clashes. If you feel that you are building or developing a function that actually can be more generic, I would go forward in the package with what you do, but then to submit a proposal to either data API or stats API, depending on what kind of functionality this is, to discuss whether a common API should not be introduced. And let me give you an example of a recent effort that we do exactly in this way. So this is related to metadata. So there are many storage formats like Parquet or Arrow that are currently supported in Julia that allow storing table level and column level metadata. But we do not have any currently. There is a generic metadata package for Julia that allows you to attach metadata to any mutable object, but we have not standardized on how metadata should be handled for tables. So what we did is the following, kind of what you have described. So we went forward to define an API for metadata in data frames. That is an open PR in data frames, but in parallel, I have opened a PR to data API to standardize what metadata should be on a table level. And why is it important? Because after we are done with this, then there are simple PRs to Arrow.jl and Parquet2.jl that don't have to be data frame specific, but can be generic. And we will immediately have the ability to save and load tables that have metadata, and automatically they, in a data frame, you will have this metadata. So at least what I do, and actually, if someone is interested, this is an ongoing effort right now, that if I add functionality that I believe is more general than just data frames JL specific, I in parallel open appropriate PR or issue depending on how mature the idea is, to either stats-based storage, stats API or data API to discuss a more general solution that can be done this way. Actually, there is another example of this, just to give you a brief example of such a situation. And this change was actually prompted by some needs of the users. So there is a commonly used function is in R that is expand grid. And then we discussed, okay, it would be nice, it would be nice to have it in data frames. But then we realized that actually this is not data frame specific functionality. Any table could be expanded like an, you could define a Cartesian product of input columns. So what we ended up doing is exactly the same. So we added a function to the data API that says, I give you columns, I give you a target table type and materialize it for me. And in data frames, we just have a specific implementation that uses this general API, but you say just, okay, and the target should be data frame, and then data frame is materialized. And of course, the risk is that some users might feel that this is an overkill that we add this data frame, but I think it's not that bad because you are explicit. But at the same time, if someone in the future wants some other table type to support the same, you will have the same function. And on the other hand, I think that this concept that you have many table types in Julia is something that people learn very fast, because when they read their first CSV file and use CSV read, they learn immediately that the second argument they have to pass is the type of the target table that they want to use, because data frame is on one of them. So if you want data frame, you have actually to explicitly say that you do CSV read into a data frame. So at least this is what we do. And those two examples are just of recent kind of this approach. So what I would suggest is that go forward with your functionality as fast as you can, because we need new functionality. But if you feel that there is some part of it that is more general, just open an issue or PR to the API package to make it generic.
Okay.
Just one question to everybody here. So specifically to Professor Bogumil. So you mentioned stats API, you mentioned data API, and I know about tables.jl and how beautiful it is, and it has eased the conversion from one table type to another. But are there any other such packages which are defining these interfaces? And as package developers, we need to be, from what I understand, is we need to be aware of each of them just to, just to know where to even, raise a PR and such a thing exists, right?
Yeah, but that's why there are not many that packages. Actually, there are only two interface packages, at least in our ecosystem, which is this data API and stats API, because tables.jl is not an API package, because tables.jl defines an interface, but also provides implementation. The point of data API and stats API is that there is no or almost no implementation. It's just a definition of API. It's like, abstract function. I would say that. I don't say how it works. I just say what it does, and everyone who wants to support it can reuse this name. So then there are no name clashes between packages. Okay. So in general, and of course, then there is a tension, does everyone follows this? But I think that if I am maintainer of some package and I learn that interface package defines some common function, then I'm likely to follow and just extend this generic definition. Maybe one small comment is for the people who listen to this, why do we want packages that only define interfaces without implementation? The reason is that this approach ensures that those packages have very low dependency, like burden. So they do not introduce many dependencies on yet another packages. Plus, if you depend on such a package, you do not add a lot of compilation time. to your package, because those are super lightweight packages. So there is no risk that someone will say, I don't want to depend on this interface package because it's too heavy for me. They are on purpose very lightweight, so that you don't have to think whether I want to depend on them or not.
Okay.
Okay, thanks a lot, Bogumil. Sourish, you should build it into the de facto standard, and then we should come back and think about how it can be generalized much more. So, are there any other thoughts and comments? For the rest, I will bring this conversation to a close. I thank all of you for having been here with us, and look forward to engaging with everybody who watches this video through the future of the Julia statistics ecosystem. Thank you. Has the recording stopped?